All right. Sound good? All right. Welcome everybody. You made it. TechEd 2013, the last day, the very last session, and you're all still standing or sitting. So, congratulations on that. Y'all are rock stars. My name is Tony Champion, and we are going to be looking at the background APIs that are available in the WinRT, specifically for Windows Store app development. We are going to have a pretty straightforward agenda for this session. The first thing we're going to do is look at why we're here. And there is a couple of specific reasons why you have background APIs in the Windows Store space to begin with, and we're going to go cover those. And then after that, we're going to dig right into the background APIs themselves and kind of go through the different options that are there and look at each one in a little bit of detail. My goal for you when we're done here today is for you to have a decent understanding about what these background APIs are and why and how you might need to use them in your apps, so that as you're going through and you're developing your Windows Store apps, you can make those decisions on where these come into play, and you can handle any of the pitfalls that you might find along the way. So with that, we'll jump right into it and start talking about why we're here. So with background APIs exist because when you think of Windows, and you've heard people talk about the development of Windows, they talk about things like efficiency and performance and battery life and all these little things. And the Windows team did a great job in developing Windows 8 to be a lot more efficient than Windows 7 was. But how that, for Windows Store app development, that kind of gave us a little bit of a hiccup. And we got a new application lifecycle for your apps. If you're a traditional desktop developer, your lifecycle is pretty straightforward. The user launches the app, goes through some startup events, and the app runs. And it runs until the user decides to close the app. And there's a couple of shutdown events, and it's over with. And it's a very simple, straightforward life cycle. In the Windows Store world, it gets a lot more complicated. To begin with, your app gets launched. Right there, there's a little bit of complication because there's actually 12 different ways your app can be launched, depending on how you're taking advantage of it. If you're taking advantage of some of the contracts and some of the extensions that are available in Windows, there's a ton of different ways your app can get launched. But if let's take the first, the normal example, the user opens up the start screen, selects your tile, and it launches your app. And your app is running; it's on the screen. And as you probably know, that you can have up to 2 Windows Store apps on the screen at once if you're using Snap View. But that's it. So what happens when the user's using your app and they switch to another app? Well, your app goes in the background, and for performance reasons and battery life and all that kind of stuff, Windows will actually suspend your app. Now, it will keep your app in memory. It doesn't affect any of that. It just takes it out of the executing thread. So what that means for us as Windows Store developers is instantly your app is broken. It's no longer running. And that can cause a whole host of issues depending on what kind of apps you're developing. Just to kind of continue on with the life cycle, because it is important even outside the scope of this talk, you are notified when your app is being suspended. You get 5 seconds of time to do any kind of cleanup that you want in your app before your app is suspended. So that when you're developing your app, you need to be aware of that. You don't have time to make real costly web calls to push data up or things like that. So you need to, you're going to have to be forced to do things like incremental saves and save the state of where you're at and things of that. When the user returns to the app and your app fires back up, you do get a resuming event. So then you can do any kind of catch up. You can get the latest data or whatever the case might be. There's one more step in this process, and if your app is suspended and the system resources are starting to get low, Windows can terminate your app completely. Now, you do not get notified of this step. So from a user perspective, what happens if you don't handle this correctly is they're using your app, they switch over to another app, and they're using that. System resources get low, they come back to your app, and they're starting from scratch if you don't handle that, and it's a bad user experience. So you really have to take in consideration this whole life cycle through the entire development of your app. But for us, for this talk, the biggest part is once you get to that suspended state. Your app is no longer running, and if you're doing a whole variety of different things, the user is expecting it to be running, comes back, and they have a poor experience because your app wasn't doing what they thought it was. So the types of apps that this affects, first is any type of app that's uploading and downloading files. For example, with the SkyDrive app, you can push files up to your SkyDrive account. Now, if I want to push a large file up to my SkyDrive account, depending on my network connectivity, it might take a few minutes, 5 minutes, whatever the case might be. I don't want to have to sit there and wait for SkyDrive on my, leave SkyDrive on my desktop while it's uploading. I want to go off and do something else. But I don't want to go off and do something else and come back 15 minutes later and realize that SkyDrive hasn't done anything because it's been suspended in the background. Another example is music. Most developers really like their music, and it's very commonplace to see people using music. But you're wanting that music in the background. Do you really want to have to take a valuable screen real estate to have your music player on the screen so that you can hear the music? You'd rather be, you'd rather have something else in front of you. But if that app isn't playing the music in the background, if it's suspended, then you have a poor experience. Another is instant messaging. Skype's a perfect example. I keep my Skype open all day long. I get messages all day long when I'm working, but I don't want to have to keep Skype on my screen. Now, if I have it open and I switch over to another app, I expect that if I get a message that I'm going to be informed about it. And this is how your users are going to, what your users are going to expect as well. And if you don't handle, if it's in the background and it's not running, then you're not able to perform those updates. This also translates over to line of business apps in pretty much the same type of way. Real-time communication apps. If you're running connecting to any kind of socket and trying to pull in data, once this app gets suspended, that connection breaks. So if you're expecting that continuous data feed from a real-time app, you lose that. Large data transfers is the same principle. If you're pushing up large files, downloading large files to do data processing, that type of things, your users aren't going to sit there and wait for it. They're going to switch over to another app, sits in the background, and you still need to be able to transfer that data. And if you're doing periodic updates, I do a lot of enterprise applications where we're constantly updating data and showing, updating graphs and charts and keeping the user informed of what's going on real live jobs and stuff. Again, this still needs to work even if the app is not visible, because the user is expecting your app to be working. Now, even though we have the trouble with the application lifecycle and kind of the headaches that brings, there is actually some opportunities that come along the same path. Users are expecting your apps to be more connected, to be more in tune of what's going on in the device. If you look at the experience that you see on a lot of things with live tiles and with toast notifications and stuff, users are coming to expect that from an app. And so you could take advantage of some of these background APIs and do things like when the user logs on, you can update your live tiles or send them a toast notification or do something along those lines to let them know that your app is running, to give them the latest information that's going on in your app. Or a classic example is the internet. If your user's been using the device, say on an airplane, doesn't have internet connection, and you have some kind of a mail app, when the user gets to the airport, turns the machine on, plugs it, gets on the Wi-Fi there, instead of having to open your app and tell your app that, hey, I need to go out and check for a new mail, if your app can automatically do that because it detects that their internet's available, that's a great user experience. There's a bunch of other things you can do, like time zone changes. User bounces into a new time zone. Maybe you need to update scheduling and things of that nature. All these types of things, if you can start taking advantage of them in your app where they make sense, it will allow you to give your users a much better user experience. So we've got a challenge, we've got some opportunities, and there's really a great set of APIs that allow you to kind of address some of those. And we're going to go through them. This kind of breaks down to 3 categories. And the first one we're going to talk about is playing audio and video. The classic, I want my audio to play when the app is in the background. Now, I get asked the question a lot. It's a common question. If you're doing Windows Store development, are you going to do an HTML? Are you going to do an XAML? Which is the better route to go? And there's, we're not going to really get into that now. But most of what you do between the two stacks is that when it comes to the Windows RT is the same. The controls are the same. The APIs are the same. There are some differences, and I wanted to point a few of those out as we go along, because most of the talk will be focused on the XAML stack, but there are a few things that when you start getting these edge cases, talking about in the background APIs, there are some differences. The first one is here. If you're doing audio or video in a XAML stack, you're going to be using the media element. It will do both audio and video. You can use it for sound effects, a whole host of different things, but you typically are going to use a media element unless you're doing some very low-level audio. On the HTML stack, though, you're going to use the HTML5 audio and video tags. They work pretty much the same way, but there is a difference, and it's worth pointing it out. If you're going to do audio in the background, though, you have three things that you have to do. The first, in your app, in the app manifest, you have to do a background task declaration. You need to select audio, and you need to put an entry point in. And this entry point, for this particular case, will be actually the app class that gets started for your project, the main entry point to your project. So in most cases, it will default to the solution name .app. If you've got a different app object that you're spinning up, it needs to point to the appropriate one there. The next is you have to assign an audio category. There's about a half a dozen different audio categories that you can assign to a media element or to the audio and video tags. But there's only two that we're really concerned about that will support background audio. The first is the background capable media, and this is your traditional category. So anything, when you're playing back music, playlists, local videos, and stuff like that, typically what you're going to use is this background capable media. The second is the communications, and this is for voice over IP, real-time chat. And the real difference between the two of these is that if you set the category to communications, it will take advantage of any Bluetooth connected devices that's connected. So it will push audio through the headset versus the speakers on the machine without the user having to do any type of setup. So these are the two that you're gonna that you'll be using. Setting them is pretty straightforward. In HTML, it is a little bit different. You have an MS audio category attribute that's added to the audio and video tags. And from the XAML stack, you can either define it in XAML as you would as a property in XAML, or there's an audio category enum that you can map it to that way. The third thing you need to do is you need to register for transport controls. So if you have audio playing in the background, the user still needs to have some level of control over that. And most of your keyboards these days have hardware controls for playback. You'll have volume controls. You'll have possibly have the play and pause, stop, next track buttons on your keyboard. And if the user takes advantage of those when your app is not when you're playing media in the background, if they select any of the buttons, you get what's called the system transport controls, which looks like this. It'll show up in the top left corner of the screen, and it gives the users the ability to have some interaction with the audio. And it does things like it allows you to toggle off play and pause, do tracks, adjust the sound level. You can add audio information, and all this but you have to register for this in your project. Doing it from a XAML side is nothing more than adding some event handlers. There's a static class called Media Control that's in the Windows Media namespace, and it gives you direct access to the transport control. And what it does is you have to, if you assign event handlers to each one of these functions, it will light up those features for you. Now, these four I have here, the play, pause, and stop, those events, those are the four required ones that you have to play audio in the background. If you don't assign event handlers to all four of those, it will not, your audio won't play. So to show you this example of this, I have a small project here. As you can see here, we've got I've got my audio set and my declarations for my background task. the entry point for the app. And then on our main page, we added a media element here, and went ahead and set the audio category in the XAML. The third thing we had to do was to map the media controls, so we did that here. And in handling these, one of the caveats you need to handle this is, since you are talking about jumping outside of your app when you're dealing with the media controls, these events come back on a different thread. So you need to handle that appropriately. So when it comes back, you're not able to make modifications to the media elements or any UIs on your app without spawning off a different thread. So that's an important part. But as you see here, we have some play, pause methods, and all it's doing is it's either playing or pausing the media control and then updating our UI a little bit. Now, when you fire off those events actually don't do anything to your audio. So if you add an event handler for stop, and the user presses the stop button, and you don't do anything with your media element, the audio will keep playing. So you do need to actually wire these up and do something with them, or they won't work as they're expected. So run this, and we'll see how loud this is. So we have our audio. Fast in the background, still playing. And we have, let's see if I can get that to come back up. And you can see here we have pretty much what your minimum media control is. By default, if you don't say anything else, the name of your app just shows up at the bottom here. We'll come back over here just to show you that there are a couple other properties you can do. So take advantage of the artist name and the track name. Rerun that. You can see here, we can update that. Now you can also use, there's a few steps you have to do, but you can also update, you can add a thumbnail to this as well if you have imagery to add to it. All right, so the next one we're going to look at is transferring data. So the uploading and downloading files. And to do that, there's a background transfer API. And the goal of this is basically to take the process of uploading or downloading a file and move it outside of your app. So this process is registered with Windows, and Windows handles this for you and gives you some feedback on how it's going. So that way, if your app is suspended or terminated, this process keeps going. It does provide feedback for you on how it's progressing, if it's completed, if it's paused or canceled for any reason. And if your app is suspended when it comes back, you're able to resync and reload those operations to find out where they're at. So as far as the user is concerned, even if your app is terminated during the process, they don't know any difference. Everything continues on as they expect it. And when your app comes back up, you can get the current status of where everything's at and update the user then. It currently supports a few protocols. You can use, for uploads and downloads, you can use HTTP and HTTPS. You can download it for FTP, but you can't upload currently. There are a few security schemes that it supports. Your basic username and password, your basic server credentials. If you have proxy credentials, that will work as well. If you use cookies, or if you need to create any kind of custom HTTP headers, you can do that when you set these up. One of the other benefits for the background APIs, they're optimized. They're optimized to do what they do and to do it well. And they're designed for power efficiency. They don't just necessarily blow and go and try to shove everything down the pipe. They do it in a smart way. They do it, it operates at a very low level. It also does a lot of network recovery for you. So if your internet connection drops out, or there's a hiccup, or packets get bounced around, it would auto recover for you and handle that. Even if if your bandwidth drops a lot and it needs to scale back, it'll do that for you. Another nice feature as well is that it allows you to do a cost policy. So when you start talking about Windows 8 and you start talking about tablets and devices like that, you're going to start seeing more and more people using mobile carriers for internet connectivity. And obviously, if you're paying for your bandwidth, you don't necessarily want your apps pushing up or down large files because it gets quite costly. So you can configure this in your app. And by default, actually, if you are on a metered connection, it won't perform the uploads and downloads. It'll keep them paused. But you can adjust that and allow it to make those transfers if you need to. So transferring files, I'm going to be talking about downloads, but as I talk about this, you need to remember that there is a corresponding upload. We start off with a background downloader, and again, there's a background uploader that does the exact same thing, just things move the other way. And you use this downloader to create a download operation. This download operation is kind of the key of what you use in your app. From this operation, you're able to do things like check the progress, get status updates on how it's going. You're able to have some control over it, whether you want to stop or pause or resume it. But everything kind of centers around this download operation. Creating them is pretty straightforward. You create a background downloader. Then you basically use a create download method and say, look, I have a source, I have a destination, and it fires off your download operation. And then from there, you can go ahead and start it with an async call, and it will be processed through Windows and start the download. If you leave your app is suspended or terminated, and you come back and you want to reconnect and find out how where everything's at, there is a get current downloads async, so you can basically get a collection of all the downloads that are registered for your app, and then you can go through there's an attach call, so you basically reattach it, reactivate all the events, and you can progress as normal. And it will give you everything that's updated. So if it's downloaded an extra 20% over the time that you've been suspended, you'll get that notification. The third one that we're going to talk about is background task. Now, for most people, background task is where you're going to be using your background APIs. They're basically a block of code that will execute outside of your app, and it's in response to some type of event, whether it's a system event that's going on or a periodic timer goes off. There are several of them. There are several options out there, and these will actually continue to fire, and even if your app is suspended or terminated. In fact, your app doesn't ever have to start. If you've registered for an event, say the user log on, the user, that's in the system. So if the user shuts down the machine, restarts the machine, and logs on, they've never started your app, you'll still get notification of it. So your app is pretty much always live, always on. The biggest thing about background tasks, though, is they have to be small. They are constrained by resources, CPU time, network resources. We'll get into that, but the goal of this is to be very small. And the reason for that is, I said before, the reason we have the life cycle is for battery life and performance. By using these background tasks, you're basically going around that, right? You're getting away from the spirit of trying to preserve that. So this is an effort to try to keep you from really hammering the user's machine and draining battery power and things of that nature. They really try to constrain you here. You can't talk about background task without talking about the lock screen. If you're unfamiliar with the lock screen, your machine can have up to 7 apps on the lock screen. From a user perspective, it's basically allowing your app to be on the lock screen and give you a little bit of feedback about what's going on in the app. But this also has a direct effect on background task and what it allows you to do. Because what this is doing is the user is giving you basically permission to run at a little bit higher elevated state. As when it comes for background tasks, some of the things that you can do is things can run longer. You have access to more network resources. There are more. You can fire your events more frequently, and there's a lot more event opportunities that you actually have, and you'll see that as we go through these slides. You can, from code, you can actually ask the user to add your app to the lock screen. You can fire off a method. It will prompt the user to add you to the lock screen or not, and the user can add it right there. So the user doesn't have to actually go to the settings and add your app to the lock screen that way. Now, there's a caveat here. You can only do this once per app. So the user starts the app. You can ask them to put your app on the lock screen. They can say yes or no. But if they say yes and add it and they come back and remove it later, or if they don't add it now, you can't ask them again. And this is to prevent you from hammering your users to keep adding it back to the lock screen. So if this is important and it's something that your app has to be on the lock screen, you're going to have to take other steps to inform the user of what's going on. As far as some quotas, you do have quotas, and we'll start seeing where the lock screen comes in here. For CPU quota, if you're not on the lock screen, you have 1 CPU second is all your background task can take. It doubles out if it's on the lock screen. Still not a lot, but at least you get that extra second. For periodic calls, if it's not on the lock screen, it's 2 hours is as frequently as you can run. You can run these things. If it's on the lock screen, you can do it every 15 minutes. So you can see that you start seeing some differences there. The network has quotas as well if it's on battery power. You don't have these. You don't have quotas if the device is plugged in. This is solely trying to keep the safe battery life. But if you're not on the lock screen and you're on battery power, you basically get 7.5 megs of throughput for a given 24-hour period. If you're running at 1 megabit a second, it scales accordingly. So if you're running at 10 megabits a second, you can multiply that by 10. If you're on the lock screen, you basically get 6 times the amount of bandwidth. The other time when the quotas aren't accounted is if you have background tasks that are running when the user's actually running your app. Because if the user's running your app, basically the theory is that, well, the user's running your app, it's okay for your app to be talking to the network. We're not going to constrain you there. Every background task you have will have a single trigger. And there's five of them. And we'll go through these actually in a little bit of detail. But the first one's control channel, and that's kind of for your sockets and your background data connections. Push notification works with the Windows notification service. The maintenance and timer, those are your 2 periodic triggers that you can schedule at given time intervals. And then the system event, which has a collection of different events that can be fired into the system. Out of all of these, the maintenance trigger is the only one that doesn't require to be on the lock screen. And the system event has about 2/3 of the system events you don't have to be on the lock screen, but the other ones you will. So as you can start to see that this lock screen really does play a big part in your decisions as using background tasks. There's also the concept of conditions, and you can add multiple conditions if you want to your background task. But the goal of the conditions is simply to preserve battery life and performance, and keep your background task running if it's not set up to succeed. So, in the case of internet connection, if you're going to download something from the internet on your background task, if the internet's not available, there's no reason for your background task to run. So you can set a condition that says, only run if the internet's available. As far as background tasks go, you have the internet's available and unavailable, if a session's actually connected or not, and if the user's actually present at the machine or not. So you can use these in any combination. The only thing to watch for is to not make it contradict your trigger. So if your trigger's firing off when the internet's available and you have an internet unavailable condition on your trigger, it will never fire. So you do need to make sure you have those set up appropriately. If you are going to use background tasks, there's some things you need to do to kind of prep your solution for it. Again, we have to declare it. Last time we declared audio, the rest of them are here. That's what the rest of these are for, is on your background task. The entry point's a little different. The entry point is actually the class that you're using that's the background task. So you'll need the full namespace and the name of that class. If you are using multiple background tasks in your app, you need to have a background task declaration for each one of them. Now, you can register the same, if you have the same background task that you want to run on multiple triggers, then you can register that in the code on multiple triggers, and you only have to declare it in the declarations once. But any background task you want to use, you do have to declare it here in the app manifest. The next thing is your background tasks have to be in a Windows runtime component. You cannot put the classes in the app itself. You can't put it in a class library. Any of those, it will not work. It has to be a Windows runtime component for them to operate. And the biggest gotcha that you'll get, and it tripped me up a couple of times, even though I knew better, and it's typically the number one gotcha that I find when people do it, is when you add a background task project to your solution, when you have to have a reference from your main app to that project. If you don't, they won't fire. And most people, from a development standpoint, think it's pretty straightforward. How are you going to it's a given. You'll have to add that reference. But what happens when you register a background task, you don't ever actually create an instance of that class. Therefore, it will compile and it will run without that reference being there. It's just your background task will never fire. So if you are going through this and you're creating background tasks and you're finding it's never firing, that's typically the number one reason why it will not fire. So that's the first thing to check. So when you're defining tasks, you're using the iBackground task interface. You will notice that all your classes have to be sealed, and this is a function of the Windows runtime component. Everything in that library all the classes have to be sealed, or it will not compile. The iBackground task and most of your background task stuff is objects are found in the Windows application model background namespace, so you'll find most of that is. And the iBackground task has a single method. It's a run method. Run method passes in a task instance, which is the process that's actually running that task at the given time. So it gives you a little bit of opportunity to hook in some events and to find out, to keep track of what's going on there. If you're going to do any kind of async operations inside of your background task, you have to get a deferral from that task instance, because if not, the process is not going to wait for your async to come back. And what will happen is in this particular case, your process won't finish correctly. So you grab a get deferral, which basically tells it to hold on, that you're doing some work. You do that work, and then you call a complete method on that deferral. You have to clean up your code and call this complete method. Or what will happen is your task will hang, you'll hit into your quota, and your task will end up failing instead of completing correctly. Creating background tasks are pretty straightforward. There's a background task builder that helps you out, that packages all the pieces together and registers it within Windows. You need a unique name. The name doesn't have to be unique across the entire machine. It just needs to be unique for your app. You have the task entry point. As I said, this is where you're registering your background task. Obviously, you see here it's a string. So again, it will compile even if you get this wrong or without that reference in there. And then you can add your triggers and your conditions, and then you call a register and it sends it in and it registers with Windows. Once you've registered it, there is a collection that you can access inside the API. This background task registration, there's all task collections that will give you all the tasks that are registered to your app. So this is where you can go through and you can remove them if you want to. If you want to tie into them to find out when they run and when they're completed and statuses, you can access them all there. It's a great way to kind of keep house when you have these background tasks installed, because if you can register the same background task multiple times, and you are going to have you start getting a collection of them and start having some adverse effects from that. All right, so we will jump over here. and take a quick look at just a minimal background task here. What I have here is a system event trigger. In my background task class here, all it's doing is it's updating a local settings value with the date and time of when this thing runs. My main class here is where I register it. So I don't have to worry about overstepping it. The way I had it set up is I go through at the beginning of it, and I'll remove any previously registered background task, and then build in my new one here. Using a maintenance trigger, and we'll go over that in a minute, but it's basically a periodic trigger that tells it to run every 15 minutes. Give it a name, give it the location of my background task, and I kick it off to run. I'm also watching the completion event, so that anytime it is fired, I get an event notification for that. And if you can do that here, or if you're starting up your app, you can always reconnect to them here in your loop. If you're collecting the task that's already registered, you can grab that instance and map that connection, that completion in. So running this, you'll see that the last time this has been running on a machine, the last time it ran was a little while ago, and we got it to update on the we got update, and I'll show you how to debug that a little bit towards the end here. But that is all you need to fire off to register and fire off a background task. So when it comes to triggers, again, I showed you there was 5 of them, and we're going to go through them. The control channel trigger is required to be on the lock screen. You'll see this lock on pretty much on everything that's required on the lock screen to kind of give you a feel for which ones need to be there or not. The control channel is basically there to maintain long-running network connections, whether it's socket connection, HTTP connection, you're doing some type of connection to a server. The goal of it, one, is to maintain that connection, but also to kind of to take it out of your app and run in more of a low-powered state. What your typically use case is for connections that have periodic data in them, that aren't having a lot of data coming across the pipe, but you need to know when data does come through. Well, another one of these differences, this is not supported in JavaScript. You can't get around that. You can't put this code inside a class library that JavaScript's using. From HTML to JavaScript side, you can't do it using a control channel trigger. And there's 2 scenarios here that we deal with. And one's push notification, and this is not the same as the Windows push notification. It's just a naming. It happens to use the same name, and it gets a little confusing. But and then the keep alive. These are the 2 kind of methods that we use when we're talking about control channels. So for the push notification, when you're using that kind of a trigger, it's basically you're set up to receive data from the server. So you have this process that's going to maintain a connection to the server, and it's just sitting there on that socket just waiting for data to be sent to the server. And anytime that data comes across, then your app will fire up in the background, and you'll get information coming through as far as and receive that data. The goal of this, again, is to let you run in a low-powered, connected standby state. So when there's no traffic coming across the pipe, it's sitting down close to the hardware level, and it's just sitting there waiting for data. The other is the keep alive. And the keep alive, there's 2 scenarios there. One is a server keep alive. And what this does is it wakes up your app every given interval that you set and allows you to ping the server, just so you don't have your timeouts, right? You can set that anywhere from 15 minutes to 24 hours. And you will find with this 15 minutes, you will see that a lot, whether you're dealing with background tasks, whether you're dealing with doing periodic scheduling of toast and tiles, you'll see this 15 minutes a lot as a minimum. And I get a lot of questions about why you can't go lower than that. Well, to give you a little, behind the scenes of what's going on. Windows has a background process that runs every 15 minutes. And when it runs, all these scheduled things that happen within a 15-minute block, it will run them. So if you have a interval time trigger that we'll see in a minute, and you set it for 15 minutes, it's going to run whenever that 15-minute process runs. So the thing that you might see there that you're not expecting is you don't know when that's going to run. You schedule it. It might be 15 minutes from now from when it runs the first time, or it might be 2 minutes, depending on where you are in that 15-minute cycle for Windows. So you'll see this minimum a lot, and that's how you're not going to get around it, and that's the reason why. The other is a network keep alive, and this is kind of done more from the Windows side, and there's not a whole lot of interaction you have there. And this is set up for proxies and IP translators and things of that. And what this will do is Windows will maintain that connection for you, and they auto-adjust on how often it needs to make that connection. If you are finding that you're still getting timeouts, you can't set an interval for this, but you can tell Windows that you are getting timeouts and request it to operate a little more frequently. The next one is push notifications. This is the actual Windows notifications, uses Windows notification services. And a push notification trigger will receive raw data from Windows notification services. If you're not familiar with Windows notification services, it's a great service from Microsoft where you can push data from the server to your apps. And there's 3 types of data that you can push. You can push tile notifications, update your live tiles. You can push toast notifications, and you can send raw data. If you're using toast or tile notifications, you don't have to worry about creating a background task. You can set up your app to receive these notifications, and Windows will handle the rest for you. But if you want to actually receive the raw data so your app can do some kind of action on it, then you have to use a trigger for it. You are limited in the amount of data that you push. It's limited to 5K. So there's not a lot of data, and typically you're not wanting to send a lot of data in this process. Now, this goes, especially if you line a business world, this does go through a public Microsoft service. So you're not wanting to send any kind of confidential information through there. So what you will normally find is that you're going to send commands through there. If you're running an LOB app that has confidential information in it, and you're wanting the user to tell the app it needs to go get more information, then you just send a command to it and say, look, I want you to go get more information, and then the app will wake up. It will go out and use a secure method to get that data and do what it needs to do. But never try to send anything secure across there. The other catch to this is to use Windows notification services with Windows Store apps is the app has to be registered with the store. The only way you can toggle this and register this is through the dashboard, and so your app has to be through there. This will cause an issue for you if you're trying to sideload your app in an enterprise environment. Whether this will change or not, it remains to be seen, but currently that's kind of the scenario you're at. So some of your use cases for push notifications are things like email. Instead of having a process that's continuously pinging a server looking for email, you can use push notification services to push out to the client to inform them that they have new email waiting for them. Same thing with if you're doing any kind of instant messaging client or anything like that. You can, from the server, when the user receives a message, you can send a notification to the app telling them that there's a new communication available. Or if you just need to do things like have the app go out and sync data. Again, this is all kind of a command-driven type of scenario that you're looking at. The next 2 triggers we're going to look at together because they're both periodic triggers, the time and maintenance triggers, and their APIs are actually identical. If you look at the documentation, there's very little difference between the 2. They're both time-based recurring triggers. They both can be set to a minimum of 15 minutes. Again, if it's not on the lock screen, that 15 minutes will be turned into 2 hours. But the only real difference between is the time trigger is required to be on the lock screen to run. If it's not on the lock, your app is not on the lock screen, the time trigger will not trigger. The maintenance trigger is not required to be on the lock screen. However, your device must actually be plugged into PC power. This is again, just to keep you from being able to drain battery power and that type of a thing. So that's really the difference between the two. Other than that, they operate identically. The last one is a system event. And the system's basically, the trigger fires off of some event that's happening in the system. There's a dozen different events that get fired. And out of these, you can see there's several that are required to be on the lock screen. But if you could, by taking a quick look at them, you can start to see that there is a lot of potential here. I used an example earlier with the network, the internet available. The network state changes. If one of your network connections change, you can get notified of that. Servicing complete is a great one. If you update if your app gets updated, then at the end of that update process, it will fire this off. So if you need to go through and clean up any background tasks or any scheduled jobs or anything like that you have, it's a great time to do that. If you encode, you can check to see if your app is on the lock screen or not. You can do that, but only when the app is running. If your app requires has a workflow that's requiring your app to be on lock screen, there are the lock screen added, application added, and removed events. So you can register your workflow based off of these events. So when your app is added to the lock screen, you can add the triggers that you need to in there. And if the app's removed from the lock screen, you can remove those triggers if you need to, or add a different set of triggers so that you have at least some limited functionality. So let's come over here. And I wanted to show you how some of this works. So again, I've got a project here that is set up with a Windows runtime component added to it, with my background task that whenever it fires will come through here, and it does several things. It does a tile update, also does it will also do a toast notification update as well. And what I did was I set it for the network state change. So anytime the network changes on the device, that background task will get fired, and it will continue to work. Now, when you create most of your background tasks, when you set the triggers, you always have the option of the one-shot. So you can set your background task up to either run a single time or run every time that event happens, whether it's a time-based event or if it's a system trigger like this. What we do is we run this, and I'm currently plugged into the network here. Let's see if we can kill our connection. Once we kill our connection, we get toast notifications, the screen updates, and we also get a live tile update as well. So you can start seeing how you can take advantage of that with just a little bit of code. You now have a network status app, and you can adjust your network, what's going on in your application based solely off of what the availability is. And that works on all your connections. We actually had a conversation earlier. I had a conversation earlier this week and was asked if that would work on a VPN connection. And it will. So if you connect, if your app is required to work only if it's connected to within your VPN, you can get notified when your VPN is wired in. It becomes a pretty powerful tool to use. Now, debugging. Debugging background task gets a little tricky because the process is running outside of your app, and it's event-based. So being able to replicate that event or cause an event to happen is sometimes kind of tricky. Or in a timer-based scenario, do you really want to sit around for 15 minutes just so you can test to make sure that the code inside your background task is working correctly? So there's some options there and some things to do when you're looking at debugging these things. The first thing you need to be aware of if you start running, especially running into problems, is the matching names. So as I said, here we have a background task that's it's in the background task namespace, and the class is my background task. Well, we use that in two different spots. We use it when we register it in our app manifest, and then when we register the class with Windows. And this is a great source for typos here. There's no validation here. So that's always kind of one of the first places you look, is to make sure everything lines up and matches correctly. But from an actual debugging standpoint, whenever a Windows Store app runs, Visual Studio will show a debug location toolbar in your toolbars. And in this, it has a suspend drop-down. This is actually another thing as you're testing your application lifecycle. You can force your app to be suspended. So if you want to test that workflow, what happens when your app is suspended or resumed, you can do that from this drop-down. But the other thing you have is that any background tasks that you have registered will show up on this list as well. So you're able to manually fire off those events so you can test the workflow inside your background task. There is some exceptions to this. The control channel, the push notification, and the SMS received system event will not fire off this way. And that's solely because these are events that receive data, right? So if you're doing a push notification, and when it fires off, it's coming with a block of data. You can't really replicate that in a drop-down. The event viewer actually becomes pretty handy when you're trying to track down what's going on with your background task if they're not performing the way they want to. And in the application events, there's two logs that you should look at. One's the background task infrastructure, and the other one's the apps. Now, the apps is also is a nice resource for all your Windows Store apps. It's kind of the top-level event log for when things fail. By default, you get the operational logs, which is pretty much your failures, right? That's what shows up in these. If you really want to do some debugging, some testing, then you can add the diagnostics logs as well. You do that quickly by just selecting the log, telling it to show the analytic and debug logs, and it will add that diagnostics log. You select it, and you enable the log. Now, if you do this for background tasks, you'll see real quick, it dumps a lot of stuff into this log. So if you're going to be debugging, this is a great tool, but don't leave it on. So come in and enable it, do your testing, and then turn it off, or this log gets out of control really quickly. You jump over here real quick. We come back over here just to show to the original background task that we looked at. Said I had it set for a maintenance trigger to run every 15 minutes. Come in here and put our breakpoint. We run our app. You see now we got our debug location here. And our update task that we registered, the name that we registered will show up here. Fire it, and it will debug just as you expect it to. And it's pretty much that straightforward. So I want to take a little bit of time to wrap some stuff up and to kind of give you a few thoughts I want to when you're going through this. And the first is to really be considerate of your system resources. Again, this is kind of getting around the spirit of what Windows 8 is trying to do by reserving system resources. And so by your app taking advantage of these things, you can really affect performance greatly. And the whole Windows 1 design principle kind of affects this too. You know, if a user has your apps installed and your app is beating on the system resources and affecting things like the battery life on the app, the user will have no idea really that it's your app that's causing issues with their device. The user has issues with the device, has a bad experience, and what ends up happening is the user doesn't end up, at the end of the day, is not using your apps. So you really should be considerate of that. And some of the ways to take a look at when you're looking at that is, does your app actually need background APIs? I know I've spent some time up here telling you how great they are and stuff, but you really need to look at if those things are actually important to your app. When you're looking at if there's, if you need to use them, I mean, things like I used an example early on about I write apps that will periodically get data and update the user and update charting and stuff on the screen. And we looked at, we could create background tasks to kind of keep this process going and stuff. But at the end of the day, if the user wasn't actually looking at our app, then do they really need to see updated graphs? Do we really need to go through all that process? So we decided we didn't. And there's a lot of times that your app's not going to fall in this workflow, and there's no sense in using it if you don't need to. And then you take a look at, is there a different approach to accomplish the same thing? A lot of times, what I'll tell people when they look at their process is, you can fake it. The great thing with Windows 8 is we have things like toast notifications and live tiles and stuff. And so you can do a lot of that type of stuff, and you can update your toast or your tiles with push notifications or scheduled updates that don't require background tasks. And so it's not going to have the adverse effects on the machine. And to be honest, it's not more code that you're going to have to write and maintain. So if you can take advantage of that, you can notify the user of things like when a message is coming in. You could just use a toast notification instead of having to create a background task to do that. And they still get the same experience. Your app is still communicating with them and still updating and giving them a great experience without having to go through this approach. You really need to be aware of your system constraints, your resource constraints. If you start blowing those CPU time and stuff, it is going to come back and fire, and you're going to get validation you're getting errors. You're going to have events that aren't going to fire correctly. You're going to have workflow issues and all that. So you really do need to take consideration of that. And if you're doing network downloads, you're going to have to understand that if you are pulling out data and the user is on battery backup, you are going to be constrained on those resources. And finally, really plan for that lock screen. If you're going to be using the lock screen, you have to be careful. If you're creating a consumer app, you have to be very considerate of your user. You can't beat on them and put a big message across your app saying, hey, you got to add me to the lock screen. It's a bad experience. They're not going to use your app. So you have to be considerate of that. And at the end of the day, your app still needs to run and run as effectively as it can without that app being on the lock screen. So whatever the features are you're using in your app, if it's needed to run, you need to really try to isolate that the best you can, and you need to adjust for it if it doesn't. Now, if you're on the line of business side, you have a little bit more flexibility, right? I mean, your users are supposed to use the app the way you need it to. So if you need the app on the line of business, in a line of business app to run on the lock screen, you have a little more leeway of informing the user that they need to add the app back to the lock screen. But either way, you really do need to take that in consideration. You've probably seen this slide before. It's all the great resources, all these sessions and stuff are going to be online. But there are a couple of places if you are doing Windows Store or app development you should look at. dev.windows.com, design.windows.com are two great resources. They dump you to MSDN. They are company hubs, they're hubs that have got a lot of great resource, and all the background APIs and the walkthroughs and can be found there with some great samples and all the detailed documentation and stuff. Again, you've probably seen this. And so for that, we have a little bit of time. I'm free to take some questions if y'all have any. Yes? So the question is how does Windows Phone 8 handle these background tasks? And Windows Phone 8 has similar concepts, but it's done completely different because your device there you're going to have a lot more restraints on how things are run because you are always on a battery and on a very small battery. So that's constrained a lot more than what you're going to find in the Windows world. Yes, sir. My sample code will be available. Actually, I don't have a slide for this. My blog is tonychampion.net, and the slide deck and all the sample code will be available. I think the slide deck will also be available on Channel 9 as well. But I will have the samples posted probably by this weekend if I don't get to it before I leave. Yes?
So probably just worth mentioning that you, in addition to seal, you also cannot have any public members that return tasks. It's not exportable from RT. It has to be IAC operation. And you'll get a very obscure compile error that says like, oh, you're not finding this tag, or you're not export tag. So one of those other batches that you're writing async in a way that you have to actually convert it to as async.
That's true. So if y'all didn't hear that, you basically have to be very careful when you're doing Windows Runtime Component libraries because there's certain things you can't return. The reason why the Windows Runtime Component is required is because that way it can guarantee that this control will run from Windows. So it's very strict on the Windows RT aspect of things. It won't, in a normal Windows RT world, if you're doing like your main app, in that type of scenario, you have a blend of Windows RT APIs and the .NET framework. When you're in a Windows Runtime Component, you have the Windows RT, you don't have the .NET framework control. So you have to, things like task, you need to return the right type of task that it's looking for and things like that. All right, well, I appreciate everyone coming out. Everybody enjoy the party tonight. I hear it's going to be a lot of fun. You can find me online, easy enough, TonyChampion.net. If you have any questions other than that, I will be around here for a little while. Appreciate it.